Hi class. So far we've seen that in response to heat, heat energy imbalances, the atmosphere is going to redistribute heat energy from areas of surplus heat energy to areas where there's a deficit of heat energy. And it does this in order to try to reach equilibrium. Remember, the Earth atmosphere system is always trying to reach equilibrium. So this redistribution of heat energy takes place both in the vertical and in the horizontal, and it does so in the form of atmospheric circulation. So those air mass exchanges we were talking about, the storm systems we've been talking about, and so the atmospheric circulation is going to redistribute that surplus heat energy both in the vertical and in the horizontal, and in doing so it's going to create weather. So our question today for the section number 13, weather, nature's attempt to balance energy imbalances. We're going to take a quick look at during what seasons are these heat imbalances at their greatest, and what kind of weather do large heat imbalances create compared to small heat imbalances. And so we're going to start off by drawing the United States again. So we've got the West Coast and the Baja. We've got Carolinas, Florida. All right, there we go. And we're going to take a look at two different locations. We're going to look at Miami, Florida, and Dickinson, North Dakota. And we're going to look at these two locations at the extremes of the year, so in January and July. And so in January, if you look at temperatures in Dickinson, North Dakota in January, you'll probably find high temperatures averaging about 5 degrees Fahrenheit, while in Miami, Florida, high temperatures are probably averaging around 80 degrees Fahrenheit. Okay. And so you'll notice that that's a pretty nice temperature gradient there. And remember, whenever we have a temperature gradient, heat's going to be transferred. And in the transfer of that heat energy, weather is going to be created when heat energy is transferred from areas of surplus to areas of deficit. Okay? And so in July, in the summertime, if we look at temperatures in Miami in July, you're probably looking low to mid 90s. So let's say 93 degrees Fahrenheit. And in Dickinson, North Dakota, surprisingly, that's a really hot place in the summertime. So high temperatures probably averaging around 90 degrees. So look at the difference in temperatures between Miami, Florida, Dickinson, North Dakota in summertime. There's not much temperature difference at all. And since there is no temperature difference, there's no temperature gradient. With very little temperature gradient, there's going to be very little heat to be transferred, and as a result, the atmospheric circulation is going to be pretty stagnant. Whereas in wintertime, with the large temperature gradient, there's a lot of heat energy that's going to be transferred, and so the atmospheric circulation is going to be very vigorous. And so we should make note of that. So in January, you've got energetic weather. And what I mean by that you'll have some deep low pressures. And those low pressures, those storms, are going to be the means by which that surplus heat energy is going to be transferred from the area of surplus to the area of deficit. In the summertime, when you have small temperature gradients, so we ought to add that too. So we got large temperature gradient here in winter. gradient. I still don't know how to spell. Large temperature gradient, strong atmospheric circulation, so energetic weather. All right, and then if we look at summer, let's get back to summer now, we're going to have pretty much just the opposite. We've got a small temperature gradient. In the summertime between North and South, North Dakota and Florida. And so as a result, the weather actually is going to be pretty boring, at least in terms of atmospheric circulation. Boring weather. You're not going to have many low pressures, fewer storm systems, fewer low pressures. They're going to be less vigorous. And that's all because this is going to be a really weak atmospheric circulation in summertime because of the lack of temperature gradients north to south. So weak atmospheric circulation. So in the horizontal, there's not going to be much redistribution of heat energy because of the lack of temperature gradients. You can still have redistribution of heat energy from the surface up into the atmosphere, so in the vertical. So you can still get those strong thunderstorms in the afternoon. But in terms of horizontal redistribution of heat energy because of the lack of temperature gradients, that's not going to be much of a big deal. All right, so this closes out chapter 4, and so I'll be sending out materials on chapter 5 on air pressure a little bit later today. So look for that. Take care, and if you have questions, make sure you get in contact with me. All right, take care. Bye-bye.